Okay, guys, it's 7.1. We're in chapter 7. It's studying the solar system. A lot of these things we're just looking at the planets and the sun. Okay, let's go through. Here we go. Okay, first thing, the first spacecraft ever sent out into deep space was called Voyager. Okay, Voyager, once it was out very far, it turned around. I believe this is around Saturn's orbit. It turned around and it took a picture. And that picture is called the pale blue dot. It's a very famous picture. That is a picture of Earth as viewed from around either Saturn or Jupiter's orbits. Okay, so if you were to flip it around. Okay, there are 8 major planets in our solar system, not 9. It's the ones that you've learned about in elementary school, right? Mercury, Venus, Earth, Mars. Those are the first 4. Then you got Jupiter, Saturn, Uranus, and Neptune. Okay, those are 8. Okay, it does not go to 9s. Pluto is not part of it. Okay, Pluto, though, the one that you past knew as a planet, I believe, is now a dwarf planet. There are several dwarf planets. I think there's like 5 of them, if I remember right. And we'll talk about them in the future. They have highly elliptical orbits. Okay. What is the solar? Okay, so all the planets, one thing you have to know is all the planets, except for one, orbit, all of them orbit counterclockwise, and then all of them except for one rotate counterclockwise. So counterclockwise is the general theme for everything. Okay, they all orbit around the sun in counterclockwise, and they all rotate around in counterclockwise, except for one. That one is Venus. Venus actually rotates clockwise. We actually think it was hit by something very large in the past, and it flipped around 180 degrees, and now it looks as though it is rotating clockwise, but really, it's counterclockwise. It's just upside down. Okay, so what can we learn by comparing planets to one another? Okay, so if we look at all the planets and we can compare things, we might be able to determine maybe how our solar system was formed, what are some similarities between things that are close to the sun, maybe things that are far from the sun. These are all important things. So studying similarities and differences may help us find another planet we could live on, or it might help us find a moon or something that we could live on. Comparing with these other things may reveal patterns that will help us understand our own planet as well as other planets, okay? These are all important things that we need to do. So we need to be looking at other planets and comparing their geology, their atmospheres, a whole bunch of different things. Okay, sun and planets to scale. Okay, so look at those. Those are all the planets scaled to what they would look like for with each other. This is what you will be doing for the Chapter 7 lab, is you will be creating these on paper. You will be creating the different sizes and making sure that you can see them to scale. Okay, so planets. One thing to know about planets. They are very, very tiny compared to the very, very large distances that separate them. Okay, very, very tiny. And we'll talk about that when you are doing the Chapter 7 lab. Okay, let's start with the sun. The sun is 99.9% all of the mass from the solar system. So if you were to take all the comets, all the asteroids, all the planets, and you pile them all together into one big ball, and then you took the sun would be 99.9% of what all of the mass is there. So yes, the sun is gigantic, okay? And the sun is made mostly of helium and hydrogen, and it's mostly plasma. It's hydrogen, helium in plasma form. And what that is it's been ripped apart from its electrons, okay? It converts 4 million tons of mass in the core of the sun. Okay, so nuclear fusion occurs in the core, and 4 million tons of mass of hydrogen is formed due to that combining of mass in the core, okay? So Mercury, first thing you need to know about Mercury is it's mostly metal, okay? Almost the entire thing is just a giant iron ball, okay? It's not like Earth. We have a lot of rock, we have a crust, we have a mantle, we have magma. That's not how Mercury is. Mercury is just basically a giant metal ball. There's nothing there. There's no atmosphere. You have gigantic cliffs created by it being crushed together. Okay, and we'll talk about more about planetary geology in the future. And it is extremely hot during the day and extremely cold during the night. Okay, so you can see there. The reason why that is because there's no atmosphere. So if you're on the sunny part of the planet, it's hot. If you're on the shaded part of the planet, it's cold. The only reason why it's different on Earth, like if you're on the sunny side and the night side, they might be relatively similar because we have an atmosphere that traps in the heat. Yes? Okay. Venus. This is the one with the most dense atmosphere. Okay, it's greenhouse gases. I'm sure you've heard that it's extremely hot. It's the hottest surface temperature planet in our solar system. It is about the same size as Earth. They call it our sister planet. It's the closest planet to Earth. And we've actually, interesting thing about Venus is we've landed on it. Russia has landed on a probe on it before, but it was crushed almost instantly because it has a very heavy atmosphere and it was burned. And but we've never seen the surface other than that one time. The only way that we know what the surface looks like is through radio waves. We have probes that go around orbiters that shoot radio waves in, and when they come out, they can kind of give an idea of what the floor looks like. Okay, going forward, Earth. Okay, Earth, we have an atmosphere, right? Not as dense as Venus's atmosphere. It's a good atmosphere. We are the only planet that harbors water in all three forms, liquid, solid, and gas. Okay, because of that, we got a lot of life. And the one thing that you need to know about Earth that is very interesting is we have an extremely large moon compared to the other planets. Okay, so Mercury and Venus, they don't have moons. Okay, we are about the same size as Venus, so you would expect it to have a relatively large-sized moon if you were comparing it with us, but it does not. It does not have a moon at all. Earth has this gigantic moon that's almost bigger than Mercury, I believe, and so that's something that you need to note down, is that our moon is gigantic. Okay, Mars. Talking about moons, Mars has two of them, but they're very tiny, Phobos and Deimos. They are very tiny moons. They're like asteroids. They're not even spherical, really. It has a small atmosphere on Mars, not a very big one, not a very thick one. And it has the largest volcano in the solar system. Okay, so that's something that you should know about it. It does have water. Okay, it's in ice form. We can see it on the northern and southern caps. We have not found any liquid water on Mars, but we do see like creeks and things where we believe that water once ran. We're positive water once ran there. We can tell what water flow looks like, but we don't know how long ago that was. Okay. Jupiter. Okay, Jupiter is mostly made out of helium and hydrogen, okay? Kind of similar like what the sun is. The sun is mostly hydrogen and helium as well. Okay, there is no surface on any of these planets past this, okay? Like if you want to go land on it, you can't. Okay, there's not going to be anything to land on. On all four of the planets before that, Mercury, Venus, Earth, and Mars, you can land on them. There's a surface to walk on. These are gaseous planets. They do not have that. What you would have is if you went inside and you were able to withstand the compression that the atmosphere is giving onto you, and you're able to get all the way to the bottom, is you might find a liquid hydrogen lake that you would be able to, I don't know, maybe float on, but it's extremely dense. There's no way that anything would survive the pressure down there. It's 300 times more massive than Earth, okay? It has tons and tons of moons. All the planets, Jupiter and further, all have lots of moons because they're huge. They have a bunch of gravity. They can grab things going by, okay? Also, all of these planets have rings. Now, they aren't as defined as Saturn's rings, but they have rings, okay? Okay, something that you need to know about Jupiter. The most interesting thing about Jupiter is that if you look at it through a telescope, you can see 4 things orbiting it. Those 4 things are the Galilean moons. They're the largest moons Jupiter has, and there are the names right there. They're Io, Europa, Ganymede, and Callisto. Okay, they are very unique in themselves, okay? It's possible that some of these might even harbor life, okay? So this might be a place at which you would look for a future civilization as well to implant humans. Now, we're not thinking that there are aliens out there or anything on these moons, but we could find some microbial life or something. Okay, so one thing you need to know about Io is they have active volcanoes, okay? There's volcanoes all over it. It just looks like a giant volcano moon, okay? Europa is just a bunch of it's icy ocean, okay? The whole top of it is frozen, and I don't know how far down that ice goes, but there's an ocean underneath it of it's not going to be like H2O water like our ocean is, but it has an ocean of water as well, but it's mixed with other things. I just can't remember what off the top of my head. Ganymede, this is the largest moon in our entire solar system. It's huge. Callisto is a large moon as well. It just has a bunch of craters all over it, but it's huge as well. So these are the 4 big moons of Jupiter, okay? And they call them the Galilean moons because Galileo first found them when he looked through his telescope. Okay, Saturn. Saturn is most defined by those rings that you see on it. Okay, those rings are just a bunch of like rocks and ice, okay? It's not like, I don't know what you thought it was before, but it's just a bunch. If you were to like go through it, it would look kind of like what you might see in like an asteroid belt on a movie or something. It'd be a bunch of little rocks and ice balls all around, okay? And that's what those are. It has many moons as well. Its most famous moon is Titan. It's right there. Just like Jupiter, there's nowhere to land on. This is a picture of Titan up here. It's most known for the incredible atmosphere that it has. Going forward, I just said that rings are not solid. They are made up of ice and rocks. Okay, Uranus. Uranus also has a bunch of moons orbiting around it. It has rings. It's most famous for being tipped on its side. It's tipped about 90 degrees. It is made of hydrogen and helium, just like Jupiter and Saturn. And it is smaller than the first 2, Jupiter and Saturn. It's mostly made out of hydrogen compounds, really. Okay, so it's mostly made out of hydrogen and helium, but then it's made out of a lot of hydrogen compounds, which means that it's elements put together. Like, here you go. Here's some examples here. H2O, NH3, CH4. Okay, those are hydrogen compounds. Going forward, the last one on the list here is Neptune. It is very similar to Uranus. It is hydrogen and helium, and it has a lot of hydrogen compounds. Its famous moon is Triton. And what's interesting, what's known for Neptune and its famous moon Triton is that the planet rotates counterclockwise, just like all the other planets, but this moon orbits its planet in a clockwise direction, the opposite, which is weird. No large moons do that. All large moons orbit their planets counterclockwise, just like all the planets orbit the sun counterclockwise. So that is what's interesting about Triton. Okay, dwarf planets. So dwarf planets include Pluto and Eris. These 2 planets these 2 dwarf planets are ones past Neptune. They have highly elliptical orbits. Eris is actually a little bigger than Pluto, okay? Pluto, we thought it was a planet first because we saw it because it was closer to us first. For most of our lives, Pluto is actually closer to us than Neptune was, okay? Because it's so highly elliptical in its orbit, and Neptune was circular. It was going through part of Neptune's orbit, and it was actually the closer planet to us when I was growing up, and I was told that it was the furthest planet. Okay, Pluto's main moon. Okay, so it does have a small moon. It's called Charon. It's almost the same. It's not almost the same size, but I think it's like half the size of Pluto. Okay, so I mean, It's basically like two little planets orbiting around each other, two little dwarf planets, kind of. Okay, it is icy because it is a comet, okay? It's out in the comet belt, the Kuiper belt is what they call it. And so these two dwarf planets are very icy. Okay, the differences between the first 4 planets, they're called terrestrial planets, and the last 4 are called Jovian. So let's go through this. Terrestrials are Mercury, Venus, Earth, and Mars. They're small and made of mostly rock and metal. Okay, they are closer together, so they're very close in terms of how distant, how far away they are from each other. And the Jovian ones, the gas planets, are very, very far away from each other. Okay, our terrestrial planets have very few moons, if any. They have very thin atmospheres, if any atmosphere. And they have a surface that you can walk on. The Jovian planets, the gaseous planets, all have rings. They are made up of gases, and they are very large. They have lots of moons, okay? And they're spaced very far from each other. This is a very important slide. You need to know all those things on this slide, okay? And that is it for 7.1, and we will go on to 7.2.